In the previous lecture, I've explained this neural network, how this neural network will compute and give you an output that can be compared with the actual output, y. So A3 will be the output of this neural network, and if A3 and y are exactly the same value, then this cross entropy will be 0, otherwise it will be some bigger value. And I also explained that in order to train this neural net, which means you're trying to tweak the values of W11, W21, B1, U1, U2, C, all these coefficients. To train those values, one needs to do the gradient descent, and I also explained that gradient descent algorithm should be done like this, where the gradient has to be calculated using some sort of a chain rule, and then eventually once you calculate the gradient has to be multiplied by some learning rate, and then you have to subtract it so that as these coefficients u and w are tweaked, the difference between y and a3 will be decreasing. Okay, so I actually want to show you how this can be coded in Python. So here's my Jupyter, and I'll start by importing the usual packages. So NumPy and Pandas, and then I'm going to just make my own training and test set. So I'm going to make the Pandas data frame made from the I need to put this XOR table. So exclusive OR gives you 1 only when exactly one of the input is 1 and the other is 0. So I'm going to type this into my data frame. So it will be 0, 0, 0. And then if it's 1 and then 0, that's if those are the inputs, the output will be 1. And then 0, 1 will be 1. Whereas if both are 1, it'll giving you 0. Okay. Now I actually want to modify the input slightly so that I'm kind of thinking of an actual circuit board where the input voltages are not 0 and 1 volts, but they're like close to 0 and close to 1. So instead of 0, it could be something like 0.01 or something. So if I want that, I first have to multiply this list by 1000 so that I have a total of 4 times 1000, 4,000 examples. And then after I have those examples, I'm going to modify these values slightly by randomly adding or subtracting values there. Okay. So I'm going to do this, and then I will rename the columns as x1, first input is x1, x2, and then y. Okay, so these are my columns, and if I take a peek at what df is now, you'll see that it has x1, x2, so if 0, 0 is the input, then y will be 0, 1, 0, you get 1. Okay, now let me try to modify these values slightly, and I'm going to use the random package inside the NumPy. So what I'm going to do is in df x1, I'm going to add to it NumPy random.normal, and what the normal package does is it randomly chooses numbers from the standard normal distribution. And since I have 4,000 rows, I'm going to generate 4,000 of them. And because standard normal distributions will give you values like 1 or 2, even 3, although very rarely, and those numbers will be modifying these too much, what I'm going to do is I'm going to multiply the random values by 0.1 so that at most you'll be adding like 0.3. So if you know the normal distribution, you know what I'm saying. It's like 3 times the standard deviation happens, but rarely. So you might see one or two examples like that in this entire set. Okay, but anyways, so I'm going to do that, and then I'm going to copy this and paste it over here. So I do the same thing for x2. Okay, so let me try to picture this, like graph this, so that we know what's going on. So I'm going to use the Seaborn package, and Seaborn has this nice scatter plot. I like this much better than the matplotlib one, although Seaborn is really built on top of matplotlib. What I'm going to say is I want the data df to be plotted with x being x1, y coordinate being the x2 as the input, and the colors will be determined by the output. And we need to use some palette. I'm trying to do tab completion. All right, tab completion did work. Dark 2. And if I do that, I see this nice picture which says, yes, when the inputs are close to 0, then if both are close to 0, then the output will be 0. If one of the values is close to 1, whereas the other is close to 0, then the output should be 1. So you see that this data set is well defined, and I see that, like for example, the largest deviation from 0 is something like 0.4, so that's okay. Alright, so we're trying to look for some kind of a neural network that can that's able to group these, distinguish between these two classes. So we're really trying to build a classifier, although what it would do, it will function like a logic gate, XOR logic gate. It's really doing a classifier. And I said this in the class, in the lecture, but see, if you try to use some of the usual linear classifier, then you can't really draw a single line to be able to classify this. So if you have a support vector machine with some kind of a kernel function, you might be able to do this. Okay. All right. So let's continue. Now we should split the data set into train and test. So let's import sklearn.model selection. You can do a tab completion here. Okay. And then import train test split. Okay, good. And then train comma test will be train test split, this one. And then we're going to split the data frame, the data set that we have, into two things. Test size. So the test set will be having 30% of the size. Okay. So let's see, 4,000 is the total data set. So training set will be 4 times 3, 1,200 will be used for test, and then 70%, 7.7 times 4,000 will be 2,800. So that's going to be the size of the training set. Okay. All right. So now we get to actually code this algorithm that I wrote in the lecture. So let's see how we can do this. First, I noticed that this sigmoid function phi has to be made. So let's see. Define phi of z. It's a function where it returns 1 divided by 1 plus numpy dot exponential function of negative z. Okay. So that's going to be the, well, maybe I should say that this is the sigmoid function. And then now I have to get ready for the w and u coefficients. So I need a matrix of coefficients. So I have the u and w. I wrote in the lecture that u is really u1, u2, and c, and w is this 2x3 matrix made of these coefficients w11, w21, b1, and then the second row. So let's try to define that. So I'm going to say w equals to np array, and I have to initialize the values. And in the lecture I said, oh, let's just initialize as zeros, but then I realized that if I do that, the value that the machine produces will always be giving the gradient as 0, and it just doesn't work. So I have to fiddle with the initial values a little bit. Usually what happens is you just put some random numbers as the initial weights. That's how neural networks are usually initialized. But I tried various other things. I saw that 1, -1, 0, and then -1, 1, 0 are some good things to use. Notice that I put a dot here. This is just to make sure that NumPy knows that my list is made up of float numbers rather than the integers. It complains if you don't put this trailing dot. Okay, then u will be the np array of, and this one I'll initialize as 1, 1, 0. Okay. So I've initialized my two matrices of coefficients, and now at some point I will be doing this matrix multiplication here. I wrote it like this, but this is really, this one has to be a column vector, and this has to be a row vector. This one has to be 2x1 matrix, and this one has to be 3x1 matrix to really get a matrix that has the same shape as W. So if you see what W is, you see that this is a 2x3 matrix, right? And to multiply two matrices to get a 2x3 matrix, where you have the first matrix having 2 elements and the other one having 3 elements, you have to do something like this. Let's see, np.array. I'll just make up a matrix of 2 elements, 1, 2. And for this one, I have to reshape it so that it's a 2x1 matrix. And we use at for the matrix multiplication, np array. And if I have 3, 4, 5, these 3 values, 3 elements matrix, this one, the second one, has to be shaped as 1/3, so that you know the rule for matrix multiplication. So matrix multiplication is only defined when the second number of the first one and the first number of the second one agree, so 1 and 1. And then when the matrix multiplication is done, you get a 2/3 matrix as a result. So you can see that it really does it this way. Okay. So at some point we will have to do this reshape thing to make the matrix be to have the correct shape. Okay. All right. So now we are going to actually implement the gradient descent. So this algorithm is the gradient descent algorithm. We first have to pick some learning rate, and this one also I have to fiddle with it, some various values, and to me 0.001 seemed to work well. So this is learning rate, and we will have a gigantic loop for repetition. So neural network has to view the data set several times to actually learn the data set. So we're going to be reviewing the data set, say 500 times, and it really depends on the problem. Some of these neural networks, if they're big, they have to like repeat 1,000 times, 10,000 times, 100,000 times. So it really varies. Okay. And then for us to keep track of the total error, let's just say total error is 0. And we're going to make the gradients ready. So gradient of the matrix U will have the same shape as U, but all the values will be zeros. So this is a quick way to make a new NumPy array that has the same shape as U, but with all zeros. And the same thing for dWF. This is going to be W times 0.0. Okay. Now we are going to have to read off the values from the matrix of coefficients. So I'm going to define W11, W21, and B1. This is the first row, so I'm going to take W and read off the first row and put it into these three variables. And W12, W22, B2 will be reading off the second row of the W matrix. U1, U2, and C will be U, reading the U. And with these, now we're ready to do compute the gradient. The gradient is sum of individual gradients because of the gigantic sum. So because of this gigantic sum, what we're doing is we're taking the individual derivatives using the chain rule, and then at some point you have to add them up. Okay, so we're going to go through each x1 and x2. So you'll have to iterate through the training set. So we're going to say index comma row in train dot, and the way you iterate over a pandas data frame is you use iter rows. Okay. And then once we fetch one row, we're going to fetch the first three numbers, those three numbers, x1, x2, and y. Y is the supposed output. This is the output we want from the machine. X1 and x2 are the inputs. So the row value will be unpacked. So when a single row is obtained, then the three values will be unpacked into x1, x2, x3. So that's what's going to happen. And then A1 will be phi applied to W11 times x1 plus W21 times x2 plus B1. This is exactly what I wrote down in the lecture. Okay, and then A2, A3 are very similar. So A2 is like W12 times x1 and W22 times x2 and B2. And that's your A2. And then A3 would be phi of U1 times A1 plus U2 times A2 plus C. Okay. So we generate the prediction. So A3 is the predicted value of the machine, the neural net. And that neural network and the supposed value it should be submitting, that difference will be called the error. And just from the chain rule, we're supposed to say dUF plus equals error times np.array of this A1, A2, and then 1. Okay. On the other hand, dWF is plus equal to error times np.array. You have the first part as u1, and then times a1 times 1 minus a1. So you recall that this was the derivative of the sigmoid function. Okay, and the second one is u2 times a2 times 1 minus a2. And then because now is the time when you need this reshape thingy, so I'm going to copy this one here, make sure that's reshaped the right thing, and now do a matrix multiplication of the second one, np.array, and the algorithm that we wrote requires x1, x2, x1 as the second matrix, so let's put that in there. So that second matrix is prepared, and we reshape it again at 1, 3. Okay, so after you go through all the examples in the training, then all the gradients are added up, and we now have the DUF and DWF ready to now learn the parameters. So U and W will be changed according to this gradient, but we don't want to move too fast, so we multiply the learning rate. A very small learning rate will be multiplied to DUF, and same thing for W. W would be W minus a learning rate times DWF. This minus is because you're not going to the gradient direction, but rather you're going to the negative gradient direction, which is the descending direction. In a multivariable function, if you move in the direction of the gradient, the function increases, and you want to move in the negative direction of the gradient. So that's what's being done here. And we don't want to print all the error. Oh, I also want to accumulate the error to see what the error is like. So I'm going to add to the total error plus equals, and because error is sometimes negative and sometimes positive, let me square it so it's always positive. And because the sigmoid function gives you a value between 0 and 1, and y is also a value between 0 and 1, these two cannot differ more than 1. So it's either something close to 0 or something close to 1. That's what's going to be generated from here. And then that squared value will be added. So anytime it disagrees, it will give me some value close to 1, and then sometimes it will give you a value close to 0. Okay. Now what I want to do is, if the repetitions, say this repetitions, if repetition is divisible by 10, so every 10th time I'm going to print the repetitions and the total error, so I can monitor what's happening. I really need the total error to decrease, or else the neural network is really not learning. So that's how I know how to tweak the learning rate and all these other ones. Okay, so only when you have this monitoring of the error, you can go back and tweak it so that the machine does learn. Okay. All right. So now let's execute this. It's running. So initially 876, something like 870 out of 2800 training sets are given incorrect values, and you can see that this does go down. So initially there's a big dip, and then it doesn't go down as fast as I like. So, but we're doing 500 repetitions, so hopefully eventually it's going to go down. Yeah, it does go down. Realize that I made a mistake. This should be fetching the second row, and that's why my thing wasn't converging. Now it should. Okay, it's dropping fast. At 100 value. Wow, another 150. Yeah, so this is the right one. Yeah. Okay, it's already learning. It's close to being 0 now. 49, 34. So this means like something like 30 is misclassified. This is something like 20 something is misclassified out of the 2800, so it's pretty good. 15, 12. Alright, so we are at 10. I think we can even stop somewhere at 300. Okay, so I had several problems and realized that I had an error here. This should have been 1, and I put it as 0. So that's why my thing wasn't learning. But once I changed that to 1, everything's good now. At 270, I get the value as 3.6, which is pretty small. This probably means that everything is classified correctly. It's just that some small values close to 0, when they're added 2,800 times, they could be some values like that. And in fact, I would just stop here. I think if I go further, it might just overfit. So I'll do this. Now let me make a prediction. So define predict of df. Output would be, so what I want to do is if I feed in a data frame of x1 and x2 values, I want it to be able to give the predicted values. And this part is pretty much similar to what's being done here. So let me just copy this. So I'm just going to copy. Now, I don't need the gradient. I'll just need this much. So let me paste that here. And then I'll again have to do the iteros thing. So this much will be needed. So let's paste that over here. And then this A3 is the one that I wanted as the output, but since the value A3 is close to 0 or 1, but it's not exactly 0 or 1, let me round it to the nearest value. So output.append, I'm going to append the np.round of A3. So that when it's close to 0, this will be exactly 0. When it's close to 1, it will be exactly 1. And after everything is being appended, I want it to be returning that thing as a pandas series or pandas data frame. So I'm going to return the output as a pandas series of the output. So this is now going to give you prediction, and in order to see how effective this is to the test set, we are going to use the classification report from sklearn. sklearn.metrics import classification. I can tap complete and then print the classification report, open, and then we're going to do test of the y value, the actual value, against the prediction. So predict, then test. And let's see how good it is. Oh, just a minute. Oh, yeah, right. So in the prediction, this should be test or df.traitIteros. Okay, so I'm going to change that, and now let's see. All right, so I have 100% correct. Well, that's because our data set is kind of clean, so there isn't any outliers, so it's understandable. But that's good. So we've managed to train our neural network so that it works.